Welcome back to another video from Insectech's Android application penetration testing course. In this video, we are going to see format string vulnerabilities. To understand format string vulnerabilities, we can have a close look at this program. If you see this, it is actually taking arguments from the user as command line arguments, and we have defined a set of buffer. Basically, these two lines are not needed, but you can add them. You can remove these two lines and the application gives the same functionality, but in this case I have taken the command line argument and I'm just giving it to the buffer using strcpy, which is vulnerable to buffer overflow attack as well, so that this particular application is vulnerable to buffer overflow as well, and I'm just printing this particular buffer directly. If you observe this particular program and if you think why it is vulnerable to format string vulnerabilities, I'll just give you a quick look at another application with the same code. If you see this, the only difference between this application and this application is we are properly formatting the output here. If you observe this, we are actually asking this line to convert whatever I am giving here to a string and then print it. But in this case, we are not converting it to a string, rather we are just directly printing whatever that is given by the user who is actually running this application. Now if you read the definition, this format string exploit occurs when the submitted data of an input string is evaluated as a command by the application. So in this particular example, we are not actually properly formatting this particular output to a string, rather it is actually getting printed directly. So in this case, there is a possibility of executing the user controlled things on this particular application, which means we can actually have a look at the stack, or we can actually cause the program to halt by causing a denial of service attack, or we can actually cause a segmentation fault on this application, right? So now let us see how to do that. The first thing that I have to do is open up your program that we have executed in the previous video, and this time rather than just giving your a 1 2 3 4 b, let's give something extra. So this time what I'm giving is some %x. This actually gives you the hex formatted value on the stack. This is the way to print hex formatted values, hex values. So I'm just giving 3 more x here. This colon is just to separate so that you will understand what is getting printed over there. If you hit enter, as you can see, it is actually echoing back whatever we have entered, and it doesn't know what to print here. So that is the reason why it is actually going ahead and fetching the next entry from the stack, and this is what exactly is there on the stack. If you observe this, 41414141 is an entry from the stack because we are using ARM based system. Now if you observe the stack on the system on this particular device, we should see this particular scenario. We'll understand why it is actually getting printed. So basically, before doing this, I assume that you need to have the basic knowledge of format string vulnerabilities. Just in case if you're not understanding why it is getting printed or what we are doing here, please go through the basics of format string vulnerabilities on the internet. There are a lot of tutorials available, and then please come back so that you will understand what we are doing here, because the basic idea in this video is to show you that format string vulnerabilities are existing, or they can be run on this particular ARM based systems as well. In this particular case, I'm just trying to demonstrate how format string vulnerabilities are actually being prevented by Google by adding some security checks to your NDK. If we disable them, we can still run those format string vulnerabilities, but the idea is to show you format string vulnerabilities on ARM based systems. So even NDK is preventing them, you can actually run the same exploits on other ARM based devices. So basically this particular video is not to show you what is format string vulnerabilities, but rather to show you format string vulnerabilities on ARM based devices. right? So now let me quickly load this particular application in GDB. So what I'm going to do is GDB server and port number 8888 hyphen attach. So in this case what we are doing is we are simply attaching this particular process application directly without giving the process ID. We are attaching this particular process, we are attaching to this particular process using GDB server. Oops, what happened? We can actually attach to this particular server. First let me clear this. So let me add GDB server 8888 attach. Sorry, we don't need to attach because we are not giving a process ID, rather we can directly run this, right? So what it is doing is this particular GDB server has been actually hooked into this particular application with this particular input through the command line, and it is running on port number 8888. So let's go ahead and run your client, GDB client basically, and hit enter. First connect to this remote port so that you will be able to debug the application. Now what we have to do is we need to set up a breakpoint at this particular printf function. So to do that, I'm gonna load this particular file because we cannot actually debug this particular application. I mean, we cannot see the output for list command because there is no symbol table loaded. That is, that is how the application is compiled. So we can actually use file command to load the symbol table. So what I'm going to do is I'm gonna actually load the file ls cd object ls cd local ebi obs ls and format. So this is where your symbol file is located. So what I'm going to do is I'm going to load this into my GDB here. So file ndk and Android format, and then using object local ABI and then format, hit enter, just enter S. Now as you can see, reading symbols from this particular file, the symbol table has been loaded. Now what we have to do is just give list command, it will actually show you the program there. Now let us actually set a breakpoint at this particular line. So to do that, break 7, hit enter. Now continue running the program. As you can see, now it is actually going to execute this particular buffer, but before doing that, let's print out the stack. Big wing sp. As you can see, this is there on the stack here, 414141 422 4242 42, and these contents are currently there on the stack, and we are able to read them right from the program itself, and that is what exactly we have got in the previous output, right? If you observe the screen, yeah, so this 414141 is actually getting printed here, and 42424 is actually getting printed here, and that is what exactly we have seen in this particular case, right? And this is what is known as format string vulnerabilities, right? So as I mentioned earlier, the idea here is to show you the format string vulnerabilities on ARM platform. So that's all I have in mind for this video. Thanks for watching it. Thanks a lot.